This is part 1 of 4.1, which are all about antiderivatives. So we're going to begin a chapter that takes us from the derivative stage and goes back to the function. So as the name kind of implies, it's like almost the opposite of taking the derivative. So I'm just going to go over two examples to get the kind of basic idea of what we'll be doing. Then I'll go over the rules and some more difficult examples. So let's say we're already at the derivative stage, and we want to figure out what the function was that we maybe would start with to end up with this derivative. So what do we take a derivative of and end up with 3x squared? Well, kind of like the backwards of the opposite of the power rule. I would have had to start with x to the third, because if I derive x to the third, I would end up with 3x squared. And what do I need to take a derivative of to end up with 2x? Would be x squared. And what I need to take a derivative of to end up with negative sign is positive cosine. And the derivative of e to the x, the antiderivative, would also be e to the x. So let's take a moment to maybe pause and have this kind of sink in as to why this is the antiderivative of that. Okay, so now we need to address something. This is my function that if I take a derivative of all this, I end up with f prime equal to that. But who's to say that I don't have maybe some constant in my function, let's say plus 3? Because if I derive all of these terms, this 3 would turn out to 0 and wouldn't show up in my derivative. But how do I know the constant was 3? What if it could have been 8? Or maybe 81? Or maybe 181. So I don't know what the function, if the function has some constant attached at the end, because when I take a derivative, this constant would go away. So this is kind of just kind of a mystery. So we're going to address this in the next example as to what to do with this constant. For example 2, I have a g prime given to me as this, and I want to go back to what the function is. So g of x is going to equal, what do I need to end up with 5 as my derivative? Would be 5x based on the power rule. The antiderivative for cosine, I would have to have sine. And for this one, the backwards opposite of the power rule would be minus x to the 4th, and then minus e to the x. And because my function could have some constant added at the very end, I'm going to say a plus c, and that's just going to be some arbitrary constant that my function could have added at the very end. Alright, so now, let's go over the two basic ideas. Let's go over some notation. Just like we have a derivative notation, we have the d over dx, and then we have some function which indicates to take a derivative. This notation is to indicate to take an antiderivative. So this big S looking thing is called an integral. It's going to be written like this. It's going to be the function, so f prime. It's going to have a dx in the problem. That's going to be the variable of integration. And so if I take a antiderivative, I end up back at the function plus c, and this c is called the constant of integration. So at this example, I attach the plus c, and that c is called the constant of integration. All right. Now let's go over some antiderivative rules. So for the antiderivative rules, there's two main ones. One of them is called the power rule. I'll let you give it a pause so you can write this down. Now the power rule works for every exponent except for -1. So any exponent I have for the power of x, it's going to be x to the n plus 1, all being divided by n plus 1. And then I add an arbitrary c, the constant of integration. Now the reason it cannot work for the power being -1, let's say if I try x to the -1 dx. Well, the power rule says I add the power by 1, so -1 plus 1 all over negative 1 plus 1 plus c, which simplifies to x to the 0 all divided by 0 plus c. So really what I would end up with is 1 over 0, which is not possible. So that's why I'm not allowed to have x equal to negative 1 because of this, because I end up with a 0 denominator, and that's not possible. Alright, and the easiest one is going to be the exponential e to the x dx. So e stays itself, it's a good thing. Alright, next one is going to be the trig antiderivative, so I'll let you have a moment to pause and copy these down. Alright, and now that we have them in our notes, we can go ahead and look at a couple of more difficult examples. Alright, so example number 3 wants us to find the antiderivative of this. And I'm just going to be based on going off of what the power rule says. Alright, so I'm going to integrate this, so my integral of f prime dx is going to be the integral of 5x to the 4th plus x to the 3rd plus, and sort of like when we were doing derivatives, I want to be able to see what exponent this is, so it's going to be x to the 1st power plus 6, and the variable that I'm taking the antiderivative of is dx. Alright, I'm going to go ahead and take the power rule. It's going to be a 5 x to the, I add this power by 1, so it's going to be 4 plus 1, which is 5, all over 5, plus x to the, add this power by 1, so 4 over 4, plus 4 x to the, I add this power by 1, so x to the 2, over 2, and then the antiderivative of 6 would be 6x, and then it's going to be plus some c value. Then I go ahead and reduce and simplify. Alright, so this simplifies, the 5 reduce out, so it's going to be x to the 5th. This stays the same, so x to the 4th over 4, plus this reduces to 2, x squared. This stays as 6x, and then plus c. And that's my antiderivative for number 3. Alright, next example. Find the antiderivative of this. So the same deal, I go ahead and integrate my derivative, which means I integrate 2 sine of x. Now I want to be able to see what power this is, so I'm going to write this as x to the 1/2 plus e to the x, and it's all with respect to x. And I go ahead and look at my trig derivative, antiderivative, and notice that the antiderivative for sine is now negative cosine. So it's going to be negative 2 cosine of x plus, now I'm going to go ahead and add this by 1 over here on the side. So the power rule says you take whatever power it is, add it by 1. So it's going to be x to the 1/2 is, let's see here, 1/2 plus 1 all over 1/2 plus 1. And some quick mental math, 1/2 plus 1 is x to the 3 over 2 all over 3 over 2. And whenever you have a fraction in the denominator, you're going to flip it. So now it becomes 2 over 3 x to the 3 over 2. It's kind of like if you have a complex fraction, if you take this 3 over 2 and then it flips, and then it's going to be the antiderivative of e to the x is itself e to the x plus c, and there's your answer. Alright, so one last example to go over with today for this set of notes. Antiderivative of this So it's going to be g prime of x dx equal to 3x to the first power. If I have x squared in the denominator, it's going to be x to the negative 2 plus the cube root of x is x to the 1/3 dx. I go ahead and apply the power rule to each term. This now turns into 3x. Add this power by 1, so it's going to be squared all over 2. If I go ahead and add this by 1, it's x to the negative 1 over negative 1 plus, and we'll go over here on the side and add x to the 1/3 plus 1 all over 1/3 plus 1. So this is going to be 1/3 plus 1 is x to the 4 over 3 with all over 4 over 3. And if you take 4 over 3 and you flip it, it becomes a 3 over 4, x to the 4 over 3 plus c. And you want to end up kind of how you problem started, so it's going to be 3 over 2x squared. This now becomes negative 1 over x to the 1 on the bottom. This becomes 3 over 4. The cube root of x to the 4th plus c. And that's your answer. Now you don't have to really write this x to the 1 on the bottom. You can just put it as negative 1 over x. And that's it for this example. And that's it for this video.